Hello everyone and welcome back to the Kohi Game Engine series, where we are building a game engine from the ground up using C and Vulkan. So today we're actually going to jump in and get a couple things out of the way that we're going to need for the rest of our application development, and that is logging and assertions. And we're going to get started on those things right now. So before we jump into the video, I would like to take a second and thank the channel's partners, Eearslya and Wensheng. The partners are the highest tier of membership on the channel, so I thank you guys for your support. I'd also like to take a quick moment and thank everybody under the supporters section. All of you guys that are listed here on the screen, thank you very much for your support. It's greatly appreciated. If you're interested in supporting the channel, one way that you can do that is you can go ahead and click the join button below this video. If you'd like more information on memberships, I'll go ahead and post a link in the description below, as well as a card in the upper corner of the screen. With that stuff out of the way, let's go ahead and jump into it. So if you recall last time, basically we set up our main method and we can compile this now on Windows or Linux. So it no longer matters which operating system you are following along on, you will be able to keep up. There will be a little bit more platform specific code that we'll have to write. That's probably going to be either in the next video or maybe the video after that. But after that stuff is written, we probably won't be touching platform code for quite a bit. So, as I mentioned before, we are going to knock out logging and assertions. So I want to go ahead and start with logging. Now, our logger is going to start off being fairly simple, but we are going to be increasing its capabilities as we progress through the series. So the very first thing we're going to want to do is under our engine source. We actually probably should clean some of this stuff up a little bit. So we have our defines here, we have our test C and H. We're not going to actually need these files anymore, so I'm actually going to go ahead and delete these. And under source, I'm going to create a new folder, and I'm going to call it core. And this is where a lot of our code for that core application level that I mentioned in the architecture video is going to go. So we're going to try and keep things organized sort of in sections or in layers of architectures, if you will. So under core, we want a new file. We're going to call this logger.h. Logger.h is going to start off with two simple things, a pragma once and an include of defines.h, because we need those types. Next, we have the individual log levels. And as you see here, we have 6 different levels of logging. So we have one for fatal errors, which are errors that basically cause the application to have to crash. For example, not having file write access or not being able to open a renderer. Things that basically do not allow the application to run. And then we have our error level, which is sort of a step below that, where it's still a serious type of error, but perhaps the application can recover from it. It won't run correctly, but it could potentially still run if there's an error. Then there's a warning, which is basically saying that something happened that is causing things that are suboptimal in our application, but we can continue and it should operate as normal. Then we have info, which is just your basic level of logging for informational purposes. And then we have some additional ones here, which are our lowest levels. We have debug, which is specifically for debug level information. This is included only in sort of debug or test builds. A released build, we would not be outputting anything for debug. And the same is actually true for trace. Trace is actually more verbose, if you will, than debug. It includes very low level detail, and it's very, very verbose. So trace is going to be something we'll use sparingly, of course, because we don't want to spam our logs, but it may help us in some scenarios when we want to actually filter these things out. So basically, these last two here are only going to be included on debug builds. Whenever we get to the point when we're building a release build, these two things will not be included, and you guys will see how we do that coming up here shortly. With that, one other thing that I want to go ahead and define is what levels of logging are enabled. So we're going to have the ability to switch warning on and off, info on and off, and the same for debug and trace. And the reason that we're doing this is because maybe we want to be able to control things at this level. Now, you'll notice that there's no switch in here for fatal or error. Those things will always log, even in release builds, no matter what. Those should always be reported. So we have switches for these bottom 4, and then these bottom 2 are only included in debug builds. So to accomplish that, we're going to stick in one more check here. We're going to say if it's a release build, if this K release is defined and equal to 1, then we're going to overwrite these defines for debug and trace and set them to 0 so that they are disabled. As you can see right here, we're actually building debug, so these things won't actually get output, but whenever we switch to a release build, that is what will shut this off. As with most systems in this engine, we are going to have 2 main methods, which is initialize and shutdown. In this case, they're specific to logging. And these will do various things that need to be done in order to stand the system up. Now, initially, there won't be much of anything for us to do, but eventually this initialize will do things like create a file that needs to be there in order to be written to so that we can actually write our logging messages to disk. We're not actually going to be doing that portion until we get to some of the platform code, but I want to go ahead and scaffold this stuff out now so that we don't have to come back to this later and set this stuff up. Okay, so the next method that we're going to need is a KAPI, meaning we're going to export this. It's a method called log output. And basically what this does is it takes a level and it takes a message, and then it takes variadic arguments here, which basically works a little bit like printf, where you can supply any number of arguments to it, and it will basically take this message, treat it as a format string, and then input these parameters that you pass into that string. And this is going to be something that we're not going to use directly, but we're going to call this from our other level of logging functions. So log output is basically going to be where all of the logging output funnels through. So that is what that function is for. All right, and the next thing that we're going to do is we're going to define something called kfatal, and this is actually what we're going to call to log fatal messages. Now you'll see here it takes a message parameter and variadic arguments, and it expands to log output. And you'll note that it automatically fills in the log level here, and then it puts in the message and then fills out our variadic arguments here. If you guys want to understand a little bit more on how this works, feel free to look that up. It's a little bit compiler specific. So this is the way that GCC and Clang need to handle it in our case. But it's not a detail that I wish to sort of deep dive on, so I'm going to kind of pass over it. But this is basically how you do variadic arguments within the preprocessor. Okay, so the next one is kerror. So in this case, we basically have the almost exact same thing, except instead of outputting fatal, we output error. And we're also, just to be safe, we're going to wrap these in if not def checks. I suppose I could do that with fatal too. It's not as important for this one, but it is more important on the next one, which is warnings. So with warnings, we have kwarn, which again looks like the exact same thing. We output to log output with a log level of warning, message, variadic arguments here. But the difference with this one is we can switch it on and off. So here it checks to see if our log warn enabled that we defined up here at the top is set to 1. If it is, it goes ahead and defines it this way and says, we're logging a warning level message. If this is anything except 1, or 0 if we happen to disable it, it basically defines kwarn as nothing. So what this has the advantage of doing over using straight function calls is if we were to build with log warn enabled set to something other than 1, basically what this does is it removes the call entirely. So the call is actually not compiled into the code at all. It simply just becomes nothing. And this is a way for us to not have to go through and remove various levels of calls in the system if we want to sort of exclude them. So they are included if that level of logging is enabled. Otherwise, they're basically defined as nothing, which still allows it to compile, but compiles to nothing. All right, so keeping up with our enumeration up here, the next level is info. So same thing, if info is enabled, then we define our kinfo with a log level of info. And again, if it's not enabled, we take it out. And keeping with that same theme, we have the same for debug. So we have kdebug with a log level of debug, same exact as before, just for the debug level. And finally, the same is true for tracing. So if we decided at some point that we want to disable tracing, we could actually just come up here and shut this off and not even have to use this flag if we decided that we wanted to do that. So this seems like a lot of setup, but it's nice. It's a nice way for us to have granular control over what level of logging that we have. All right. That is pretty much it for the logger h file. Now, as you may have guessed, we also need an implementation file for this called logger.c, and we will include logger.h. And logger.c is actually pretty straightforward. There's not a whole lot that we have to do. We only have to really set up a couple of methods here. One thing that we want to do is go back to our header file, and we need to define these methods, right? The initialize, the shutdown, and the log output. So I'm going to go ahead and paste those here. Okay. And for now, these are going to do not much of anything. So I'm going to put a note in here that our initialize logging is going to create a log file, and then our shutdown logging is actually going to clean up any logging, perform any cleanup that needs to be done, and write up queued entries. So what do I mean by queued entries? So as I said, our logging system is actually going to be evolving over time. So we're going to create a simple one for now, just to get things up and running. And it's basically going to immediately spit out to the console whatever is provided to it, right? Eventually, not only do we want to add file reads and writes to this to be able to append logging information, but we also eventually are going to want to do that on a different thread, or potentially from multiple threads at once, right? And typically disk access is pretty slow by comparison. So we generally only want to do that, sort of in batches. And so what we're going to wind up doing eventually is setting up a system where whenever we log output, we'll go ahead and display the console output immediately. But the file output will sort of queue up. And then once that queue accumulates enough data to actually be written out, then we'll write it all out at once, just to keep the number of file writes down. And this log output will, this shutdown logging will make a final call to make sure that any entries that are queued up also get written out to file before we shut down. So just to kind of give you guys an idea of where we're going with that. Obviously for now, this initialized logging needs to return a Boolean. So I'm going to have that return true. And shutdown logging doesn't actually return anything, so I'm not going to put anything in there for now. So the next thing we're going to want is something temporary. So I'm actually going to put a to-do temporary up here because we're actually going to need to remove this when we get to the platform layer. But we're going to want to include stdio, and we're going to need that for printf and a couple of other things. So we're going to need that. We're going to need string.h, and we're also going to need stdarg.h, and that is actually what is going to allow us to work with these variadic arguments. One of the things that we're going to need to do is write to the console. In order to do that, we actually want to perform some string formatting. As I said before, we're basically going to take this message, we're going to take whatever is passed in here and do some formatting on that, but then we also have this log level. And so the log level, we actually want to hold also a string representation of that, and then output basically a log level prepended onto this message, right? And so what we're going to do is we're going to create a array of level strings, one for each level, right? So if we look back at our enumeration, we have our fatal, error, warn, info, etc. And here we have a array of strings, essentially C strings, fatal, error, warn, info, debug, trace. And what we're going to do is we're going to take the appropriate string here and prepend it onto the message for the log level that's passed in. The other thing that we're going to want to track is we're going to want to know whether or not what we are actually doing is an error. And basically we're saying if the level is less than 2, then it's an error. And where that less than 2 comes from is our enumeration. So you'll note that a log level of fatal is 0 and a log level of error is 1. So both of these count as errors. And that's because we're going to handle the logging a little bit differently for errors than we do anything else, at least on the Windows platform. And again, some of these things are kind of platform specific, so we're not going to use that right away, but I wanted to go ahead and get it in there anyway. So that is where the less than 2 comes from. So the next thing we're going to do is create a character array that's 32,000 characters long, and we are going to zero out that memory. Now, the reason I'm doing this is so that we do not have to do a dynamic memory allocation, because that is slow. This is done on the stack, which automatically makes it much faster than allocating memory dynamically using malloc. So we create our array. Technically, this imposes a 32K character limit on a single log entry, but as I put here, don't do that. I don't think it's going to be a problem for us. If we need to, we can always come back and address this later. But in an effort to avoid dynamic allocation, this is the way we're doing it for now. So the next thing that we're going to do is we are going to use this built-in VA list arg pointer. And what this is it basically allows us to take this argument list here, create a pointer to that, which essentially is a character array under the hood. The reason I'm using this type here is because of this reason right here, which is basically Microsoft's headers override the way that the VA list works, and it complains about some typecasting here. So in order to work around this with Clang, I'm using this instead of the standard VA list that you may see elsewhere. So we have our built-in VA list arg pointer, and then this VA start is basically saying, okay, we're going to start using this list to perform operations against it, right? And the argument that we're going to start with as our sort of last argument before the variadic arguments is this message, right? So it doesn't care about this. It basically just needs to know that this particular parameter is the last parameter that's passed in before we hit these. So this is saying that's where we need to start, is right after this. And then we're going to do a VSN printf, which takes this message, uses the pointers that we have here, the arg pointer, and takes a size of the buffer, which is 32,000, which is the same length that we have up here, and outputs the formatted string to out message, which is our buffer here. And once that is done, then we need to call VA end to clean up anything that was created and or used for this VA start. So basically anywhere we have a VA start, we have to have a VA end before we actually close out of this scope of work that we're doing. Otherwise, it'll throw an error. So once we've done that, then we now have the formatted message in a string. Great. So that takes care of this portion of it. But there is one more thing that I mentioned before where we need to prepend our tag, so to speak, or our log level onto the string. And we can't do that here because we don't know what the contents of message is, right? So we need to actually take the new out message and prepend this text to that. So in order to accomplish that, we will call sprintf, which is basically saying we want to printf to a string. And again, we're going to target out message, right? So our out message is actually both our buffer output as well as the input that we're going to have, right? We're basically going to output to the out message, and then here is our format string. So this %s is basically saying we want to use a string here, and then another string immediately after. And then we automatically want to append a new line character. This is the escape sequence for a new line, so that in the console, we actually, all of our log messages appear on a separate line. And this will actually ring true for files as well. So we're basically going to say we're going to output 2 strings and then a new line. The first string is going to be our error text right here, or level string. So it'll be one of these, whichever lines up with log level. And then the second one will be out message. And so this is how we're actually going to perform that prepend operation, is right here. Okay, so the next thing we're going to do is we're going to printf, which is basically going to print it out to the console right now. And again, we're just going to pass this into a string. So we're going to take our out message and just output it here. You can technically do this, but there are security issues with that. So it's not generally recommended that you actually proceed that way. Usually it's a lot safer to actually do it this way. So this is the way we're going to do it. This bit here is actually temporary. This is actually going to become platform specific because we have some special things that we can do on some platforms to control things a little bit differently when we have an error here. So for now, we're going to printf, which is basically just a straight output to the console. So I'm actually going to say platform specific output is a to-do here, and we will come back to that. Okay, and this is basically all there is to our log output for now. There are eventually going to be things that we're going to add to this to actually output it to a file as well, but we are not going to do that right now. We want to keep things nice and light and simple. Okay, so that does it for our logging system for right now. So I'm going to go ahead actually and go to our main.c and get rid of this include test h. Actually, I'm just going to replace that with core logger.h. And you'll note that I'm using the angle brackets here and not a set of quotes, because this is actually technically a separate location from this. So technically, this engine code could exist somewhere else on disk, and this does not require us to sort of, do a .. to go up a directory and navigate our directories that way. We can just simply do it this way, and it says it comes from one of the folders in our configured include paths. So we'll get rid of that. We'll replace that with logger h, and then in our main, we're actually going to, let's go ahead and output actually one for each of these levels, right? So we have our kfatal, our error, our warn. Just to go ahead and sort of exercise our code a little bit, I'm just going to output a message, right? And I'm just going to say a test message. And let's go ahead and we'll stuff a floating point number in there, and we'll say 3.14f, right? And that'll just prove to us that our formatting works as well. So I want to do a fatal, and I'm actually going to paste some copies of this here, and I'm going to change this to error and warn info debug and trace. Okay, and I'll set a breakpoint here on our return 0, get rid of that one, go ahead and build. And it's complaining that I have an unused variable is error. So let's go back to our logger.c, and I'm actually just going to comment this out. We are going to need that, but for right now, it's bleating about that being unused. So I'll go ahead and comment that out. Okay, so we've built successfully. So now if I go ahead and run, we're getting it twice. So it looks like we did something wrong here. So let's go ahead and have a look at that. So simple mistake. We actually need a separate out message buffer here. I'm going to say, let's call this just out message 2 and output to it instead, and then print it out. What's basically happening here is this buffer is being overwritten as it's sort of processing these arguments. And so if we go ahead and run again, we will see that we get what we expect, right? And so that pretty much concludes our logging. That's pretty much all there is to that for now. Again, we will come back and we will improve this a little bit. But for now, that is where we're going to leave that. So the second thing that I want to cover really quickly is assertions. Now, assertions are something that is very important for debugging purposes. It is something that basically allows us to assert, for lack of a better term, that something is true in the application. And if it is not true, then we can sort of halt the application, because it's a way for us to basically say, if this isn't true, we want to sort of break the application and stop it here so that we can examine the data and see what's going on. And so in core, I'm going to create a file called asserts.h. And the S there is important because there is such a thing as assert.h. It is a library in the standard, it is a header file in the standard C library, but we are not going to use that. We are going to write our own assertion functions, and I will show you why here in a moment. But it should be called asserts.h. And so the first thing that we're going to do is, like we have in the past, we are going to pragma once and include defines. And then we are also going to set a flag called k-assertions enabled. And this is basically going to allow us to turn assertions on and off, similar to our various level of debugging, or logging rather. And so we can actually disable assertions just by commenting out this line. So I put in a comment in there to that effect. So the next thing that we want to do is we want to do a quick check to see if assertions are enabled, and we're using the Visual Studio compiler. Then we actually have to treat things a little bit different than if we're using something else on a different platform. Now, one thing about playing on Windows is it does actually emulate some of the Microsoft extensions, which is why some of the things like debug break, which is Microsoft specific, actually show up in here. And so we actually need to take this into account. We can't just go purely with all the GCC extensions. So in this case, I'm going to go ahead and include intrinsics.h, which gives us the underscore debug break here. This basically halts the application whenever this is called. And so this debug break is a macro that we're defining, depending on platform, that is either defined as this debug break or built-in trap, which is what GCC uses. And either way, we can call this code from anywhere and not have to worry about what compiler we're actually using. So we'll go ahead and define that. And then this is actually going to include like a bunch of stuff, because you'll see here that we're actually missing an end if. So we'll actually close this off in a few minutes. So the next thing that we're going to want to do is we are going to want a method called report assertion failure. And this is actually going to output some information to us in a format that we can actually see what happened. So the expression is going to be a string representation of the code that was running that caused the assertion failure. A message is basically going to be a string that we can provide whenever we're asserting something, if we want to, as an additional explanation as to the context of the code that failed assertion. And then the name of the file is here. This is the name of the code file itself that the assertion occurred in. So, you know, it'll be like an H file or a C file, something like that. And then the actual line number within the file. So when this is all compiled, it will actually know, based on some things that we're going to pass it, what the code was that was running, as well as what file and line it was in. So it'll help us greatly in debugging. So the very first thing that we're going to want is something called k-assert. And for those of you who haven't figured this out yet, the K that you're going to see in front of some stuff is just for Kohi, because there are assertion macros that might be defined in various libraries and things, and I don't want to collide with those. So putting a K in front of it basically guarantees, or at least loosely, that it shouldn't be defined in anywhere else. Okay, so basically this is the assertion function that we're going to call. It's a preprocessor function, just like the logging, and we're going to pass to it a expression. So this ultimately needs to evaluate to a Boolean expression, similar to if you were to put it in an if or an else if type of code block. And so what we want to do here is we want to say if the expression evaluates to true, we do nothing. Otherwise, we actually want to report the assertion failure and call debug break. Now, you're probably wondering why I don't just do this. There are situations where just checking not like that might not be enough. You could wind up in some situations where there's like a double negative, things like that. So it's always better to evaluate the expression here as being true first. And if it is not true, then we proceed with reporting the assertion failure and calling debug break. So that is it for the assertion. You'll notice in here that when it calls assertion failure, this pound expression is basically saying, take what's passed here and spit it out as a string. We are not passing anything in message for this. This underscore file underscore is a macro that basically takes the current file that this appears in and outputs it as a string. And the line does the same thing with the file's line number, except as an integer. And so that is sort of how this works. And so obviously, if we are hard coding message to be nothing here, then we need one that allows us to provide a message. So we have kassert underscore message. And all this does is it's the exact same thing. It just, instead of passing an empty string here, it allows you to pass a message in string format, which it then passes on to report assertion failure. Otherwise, it's identical. Okay, so the next one we want to put in here is kassert debug. So we're checking first off to see if we're in a debug build. This kassert debug is basically going to perform the same type of logic that happens whenever we are building a release build, where debug and trace messages do not get logged. This is the same for these types of assertions, because there are some assertions where we'll want to do that in a debug build, but we might not necessarily want to do that in a release build. So these two here will be present no matter what kind of build we're making, whereas this one actually gets snipped out and defined as nothing if we are in a release build. So that just gives us a little bit more granular control there. Okay, so finally, back up to this. So if our assertions are enabled, we're doing all of this. However, we have an else block here, because what if they're not enabled? Well, we can't just leave these hanging, right? Like if we want assertions off completely, we still have to define these things. And we still have to actually do the same thing that we're doing here, but for debug, message, and kassert. So right under here, we are actually defining these things as doing nothing at all in the else case. And then of course, any if preprocessor needs an end if. And so that's where we actually close that block off from all the way up here. So if k-assertions enabled is defined, then it will perform all of this. If it is not defined, it will define them as nothing. And there we have it. So the only other thing that we have to do to finish off our assertion is we've declared this report assertion failure function here, but we don't actually have an implementation for this. And where it might make sense to just create an asserts.c and define it there, it would really be the only function that's there. And what this is ultimately going to do is call our logging anyways. So I'm going to go ahead and define this in logger.c. And this sort of emphasizes a point in C where you don't necessarily have to include the implementation of something in a file with the same name as the header file. So just because this is asserts.h doesn't mean that its implementation has to be asserts.c. We can actually put its implementation in logger.c. And so that's actually what we're going to do right here at the top. We're going to define our report assertion failure within our logger.c. And the reason we're going to do that is because we want to call log output. Okay, and log output, of course, calls this same method down here, passing fatal, and then it says assertion failure, the actual failure, what the message is if it's included, otherwise it'll just be an empty string, in file and line number, nicely formatted for us so that we can actually see what's going on nice and easily. Okay, and actually, we do not have a couple minor things here I should fix actually. First off, this K API does not belong in the C file. That should only be in the header. And this probably should be exported as well. So it is available outside of the library. And then this is calling log output, but log output is actually not defined till down here, which is going to be a problem. So actually, let me move this to the bottom. Otherwise, I'll have to forward declare it at the top of the file, and that's not really necessary for this. Okay, so that should be it. So let's just build this real quick, make sure that it at least builds correctly. Okay, and what I'll do now is go ahead to our main.c, and I will include core asserts.h, and I'll go ahead and kassert. So I'll go ahead and just put false here, which is going to go ahead and immediately trigger an assertion, right? Because whatever's in here has to be a Boolean. In fact, actually, let me use a better example. Let me say 1 double equals 0, right? So we know that this is not going to be true. So we should have an assertion thrown. So let's go ahead and run this. Unresolved external. Okay, that is usually because, oh, I know why. Because the logger needs to include asserts.h. There we go. Okay. So now we should run, and there we go. So you'll notice that it actually broke on that line, and we got a message in our console, a fatal message in our console saying assertion failure, 1 equals 0. We didn't get a message here, but it says, here's the actual file. Here's the line number. So you guys could probably see how this will be useful in the development of our application. So that's great. It actually broke here, just like we wanted it to, without us having to set a breakpoint. So that is pretty much all there is to logging and assertions. So that is about what I wanted to cover in this video. Thank you guys so much for watching. If you like this video, feel free to hit the like button, subscribe, and hit the little bell so that you get notifications when the next video in this series drops. And thank you guys so much for watching, and I'll see you next time.